Good morning. My name is Jeff Johnese, and I'm with Red Jack, and it's my pleasure to welcome you to the Big Data Platform and Cyber Situational Awareness Analytic Capabilities session. A few quick administrative remarks. First off, we've got a mic right up here for questions after the session, or after the presentation. I will make the remark that yesterday you had to actually speak pretty loudly into the mics in order to actually have them register. So please keep that in mind, and if you need to, just take the mic out of the stand and use it. This session is also approved for continuing education credits. If you would like to get your badge scanned at the end of the session, please get in touch with Regina Dahl, sitting right up front here. All right. So it's my pleasure to introduce Mr. Dan Bart and Mr. Bob Landreth from ID6, who will be providing the presentation, and they will be doing their own introduction. So thank you very much, guys.
Good morning. My name is Dan Bart. I'm with this Cyber SA Systems branch that's in our Analytics division in the Infrastructure Development Directorate. Today we're going to try to talk about the Big Data Platform, CSAC, and what are the components that we have there. We're also going to talk about general situational awareness and the problem that we have that we face every day and how we don't solve every problem with big data.
Good morning. My name is Bob Landreth, and I'm the program manager for the Big Data Platform. So, as Dan said, we'll be reviewing some of the background, the history, and where we're going with it in the future.
Disclaimer, we're going to have to read this because we got to kill time. Just kidding. Slide. So we originally built our presentation with a problem statement, right? So it was a bunch of words that talked about the problem that we have and facing with data every day and trying to visualize that data to make some sort of decision at the end of the process. When we look at the big data problem, you guys have heard us talk about the volume, variety, and velocity of data. Another aspect that we've been learning about is the veracity of data, which is how accurate, how factual is that data, how much can you trust that data. When you look at the diagram from left to right, you can see we're trying to illustrate lots and lots of data coming at us. They come from different sources, they come at different speeds, they come in different amounts. As we take the data through our system, we work to parse it and make some sense of it. In some cases, we call that reducing it. In doing that, we can sort the data in a way that we can interrogate the data and ask questions of it to find things that we are looking for, problems we're looking for, anomalies we are looking for. And from those, then, we can then write analytics to look for that anomalous stuff, to find the behavior-based stuff, the things we don't know we're looking for. Ultimately, the goal in situational awareness is to build a picture to help an operator or a user answer a question or make a command and control decision. One of the things I forgot to say in the front, I do want to encourage people to ask questions throughout. I think it'll make the conversation a little more fluid, too. So if you guys do have questions as I'm talking, feel free to raise your hands or step up to the mic, but that'll help keep us on topic with each slide, too.
So the Big Data Platform, as it's known today, has gone through a sort of a history of names, etc., in its time frame. So it originally started out with one name, which was called CSAC, which was the Cyber Situational Awareness Analytic Cloud. We also then went out and figured out so that this cloud employs about 40 different pieces of open source software that have to be installed and integrated to all work together to support bringing in the data for ingest, processing it, and then visualizing it. So what we did is we developed something called the Rapid Deployment Kit. And so you hear the term RDK thrown out quite a bit, but that was how we were able to take 40 different pieces of software and lay it down across 100-plus servers, right? This is a distributed technology, so it's not just one big giant server, it's lots of servers. And getting all these software to all the right components in a really limited time frame was what we wanted to do with this Rapid Deployment Kit. So you hear the term RDK, but we decided to go ahead and change the name over to the Big Data Platform to represent the operating system, the infrastructure that supports all this, and then we separated out CSAC, changed the last term to capability, and really tried to represent the analytics on top of it. So as this infrastructure continues to build and become popular, what we've seen is other opportunities for other programs that our department runs to actually get on top of this. And so rather than it being its own infrastructure, what we want to do is employ these as more applications. And so CSAC represents the applications that sit on top of the big data platform. So that's the way the terminology runs today, in case you're hearing confusion, different acronyms, etc. Next slide.
Any questions on that area?
Yes, ma'am.
Hi, you had said that the rapid deployment kits are deployed over several servers. Are those in the DISA decks, or for JIE we call them CDCs?
Yes, it's inside of the DISA decks.
So, Bob, can you elaborate on how the RDK actually works, not in just production, but people can take it to a lab or any infrastructure or any virtual environment they have?
Yeah, so that's one of the big benefits behind this program is when we developed it, we didn't want to just say, this is a DISA thing, we're going to install it on just DISA servers. And so we handed it out to a lot of the services and other folks that they can install locally within their environment. And so it came with, a set of instructions, etc. And I wouldn't say that just anybody could install it, but folks that have some experience with Hadoop and Linux, etc. We've got a set of instructions so you can install it in your environment.
Some of the limitations we see in some of our current technologies are our ability to scale that technology. Technology before this platform that we had always had to scale vertically, which we had to add more servers, more processors around the application. In this case here, we can scale horizontally and take advantage of multi-processing computing. Anything to add to that?
What's that?
He's asking, can that operate in AWS or
Absolutely.
cloud?
So it's not just physical servers that we have it set up on. We're running in Amazon. We're running in different environments that can virtualize it as well. From a processing perspective, we don't recommend if you're going to be going full production that you virtualize it. There's a slight hit when you virtualize it. But for development environments, test environments, it works great. Yes, sir.
Just a quick clarification question. How does CSAC relate to the Acropolis? I mean, where does that fit in with that? Could you go over that a little bit?
So the question earlier was, does this reside inside of a deck? And the answer is yes. What we've done is within the deck, we've carved out some space there, and there's a team that supports us called Acropolis. And all it is it's still hosted within the environment. And I don't want to call them a hosting group, but they've set up all the network infrastructure. They've got all the support folks, everybody that we need to bring these applications in and run them. So they're the O&M group for Big Data Platform. So that's another term you'll hear thrown around as Acropolis. And that's really what it represents.
Bob, since we're talking about Acropolis, can you touch on our production environments?
Absolutely. So our environments today, we've got 3 production instantiations out there. We've got one on the unclassed side, we've got one on the classified SIPR side, and then we have a private secret network that we use for a lot of the out-of-band analysis, etc. And so in our production network today, we've got about 190 servers equaling about 4.2 petabytes worth of space. To date, we're up to about 3/4 of a petabyte worth of data that we've ingested. It's coming in at a rate of about 250 to 300 megasecond. So that's our big one that's bringing in. And then on the SIPR side, it's a bit smaller. It's about 120 servers, looking at about 2.5 petabytes. And our private secret instance holds about a petabyte worth of data. But at any point in time, if I need to sort of change things around, obviously not from NIPR to SIPR, but between SIPR and I can sort of swap the servers around. This is, once again, dynamically elastic system that we can deploy different servers, expand as we need.
I try to put this picture in almost every presentation I do. It helps me to illustrate the multi-layer, I guess you could call it problem or solution to how we get at situational awareness. We always try to focus on that top layer of what drives the work we do. So that top layer is where our operators sit, and those operators can be users down to net defenders to DIB partners. They really run the gambit when it comes to who we support with the kind of data we have. And so we look to those operators to define use cases for us, and use cases really drive the solution that we build and we provide. I emphasize that because we don't build every solution as a CSAC capability. We often build solutions in our other situational awareness capabilities or information sharing capabilities that we have based on the use case that the operator or user brings to us. With the use case, we're able to then look at what data is out there and what's available. Look at the sources of data. Look at what we've already collected. This is where Acropolis comes back in, where Acropolis is a large partner with us to collect that data and help us to put it to the right places and systems that we need it. The other way you can look at situational awareness when you don't have a use case is you use data scientists. You have people on your team, on your staff, they're either embedded with operations, they're embedded in our teams, that can actually look at the data and determine what use cases can come out of that data. It helps to roll the ball a little bit to get the idea of how we can provide situational awareness to solve a problem. That data scientist has to understand the problem, though, and they have to also understand the data.
And it's a really good point that we run two schools of thought when it comes to the big data platform, right? Everybody's like, all right, you got all this storage, you got all these servers, start dumping data randomly. I got data over here, I got logs, start dumping them in there. But we're torn, right? Because you don't want to waste space by putting in what could be useless logs, but then you have the data scientists who will come along and go, well, we could find stuff in there, so put it in there. But since we don't have endless funds, it doesn't make sense to expand this thing up and just start dumping random data. So in today's world, we ask, let's think through it a little bit before we go out and we grab that log, that piece of data, etc. What do you specifically want to use it for, and what within that data do you want to use it for? So we've come up with technologies that will do the data processing beforehand, and we can actually cut up the data so that if a data field comes along and it's got 50 different fields inside of it, maybe the analysts don't need 50 fields. Maybe 25 of them are just sort of filler for the manufacturer information, something we don't necessarily need for analysis. And we can strip that out and save space. So that's just one of the debates that we sort of constantly go through is dump all the data or select the data you want.
I'll add, and we'll talk about it, or at least touch on it when we talk about our capabilities later, is that not all data is raw data either. Some data has already been processed and it comes to us that way, and so we're able to ingest processed data or documents that allow us to analyze that kind of thing too. So not everything's a sensor or a log, which is a large part of our data, but we also do ingest processed data as well. This is a program we've had it for a while. We were calling it governance for a long time. To make it complicated, I came up with an acronym you can't pronounce for infrastructure, data, analytic, integration, and management. IDAME, or whatever you want to call it, is the process by which we govern interaction with the big data platform and largely interaction with our group as you bring use cases to us. The rules and processes we put in place support this environment both internally and externally. So when we look at how we do our own internal development, we put ourselves through the same process when it comes to understanding how we're going to affect the system. We do the same thing with external partners, and we needed a process where we can bring people in to what we do. Data acquisition is probably the most challenging part of what we do. There's a legal policy oversight and compliance, we call it LPOC, that goes with data acquisition, and every piece of data has a rule around it. It's owned by someone else, it's private, it's classified. There's a lot of rules that go into it. Title codes come into account when you talk with what operators you're sharing the data with. So a lot goes into how we get data and acquire data, how we tag the data when we bring it in. So data is a huge problem or challenge that we overcome every day.
And I want to underscore that. I mean, we spend months and months sometimes getting data feeds in and getting them right. And as soon as we get them in, they change. So I'll figure out all the fields. I'll figure out how to parse it into the database. And darn it, that manufacturer made an update, and they changed their schema and changed their field. So it's not a set it and forget it. And a lot of folks think, oh, just turn on the data valve, and I'll get everything in there, and I don't have to worry about it anymore. But it's a constant upgrade. You constantly have to keep up with it. Not just from, what does the data look like, but the capacity planning aspect of it is really a challenge, because if you have a new solution standing up that you've never got that sensor data off of, and you're trying to size for it, and you say, hey, what kind of data rates are you going to be coming out of? And they go, I don't know how many users I'm going to have, and I don't know what this thing looks like when it's going to start spitting out data. And so you start sometimes sizing, just kind of guessing, and then but you have to monitor that constantly and make sure that as that data comes in, if you see the rates start to increase, etc., you're either going to have to expand your solution, or the other piece of it is how long do you want to keep that data? So, we've set requirements out there. What we're shooting for is to hold a year's worth of all data. And so in some cases that could be really challenging. But that's our goal for this program right now. If we don't keep expanding but more data sets keep coming along, we may have to start shrinking that time frame down. We'll see, but right now we're good.
The other piece, the next piece, is the analytic development management. So we have to look at how we bring other analytics widgets and applications onto the platform. What impact will it have on the platform? Being part of the Department of Defense, we have accreditation rules that we need to follow. So we bring analytics through this process to make sure they're both secure, but also to make sure that they don't impact the system. Part of that process too, and I know you guys can't see that, it's on purpose, but going to these websites, you can see this process blown out. It talks about your data acquisition requirements that go with your analytics. So just because you developed an analytic doesn't mean that you can operate it in our environment, because we might not have the data your analytic depends on. So part of the process is going back to that data acquisition piece and bringing that in, and understanding the analytic development process ties into that. The process builds around our ability to collaborate. And so we use our knowledge management system. That's the last bullet. But the other parts here we talk to are how we manage our CAB, the configuration. What's CAB stand for?
Advisory board.
Change Advisory Board. And something we've been calling a summit, which is where we bring our partners, our stakeholders in together to help understand what it is that they want to integrate into the system, what is it that the system's doing or not doing for them, and how can we be partners. And I think that Bob's going to talk some successes in that area on the next slide. If you want to be able to look at this stuff, and I wasn't able to check if these are only accessible internal DoD, but we have these portals. I know if you have a CAC, you can get to them, which is our governance portal and our data portal. Which the data portal helps you understand what data access, what data we're working on, what data we have. The governance portal helps you understand how to get a big data platform disk or an RDK, to understand the ins and outs of the program, how to develop with the program, who to contact if you need help. So there's a lot of information on these two websites. I encourage you to go see them. So I asked Bob to help me really get into this slide quite a bit. So our big data platform is used by all kinds of partners across the department. While we own the baseline and we configuration manage the baseline, we include others to come in and help interact with it, to help us build it, make it better. But moreover, we build it so we can have a common platform. So if those who take it, borrow it, use it, can share what they've developed back with the community.
Yeah, it's a really good news story when it comes to the true meaning of collaboration across DoD. We started this based off of an infrastructure that was originally built by NSA, and a lot of the services went and sort of tried to get the blueprints, but a lot of them were really focused on, we wanted to build an environment on the unclass or the SIPR environments. And the challenge was that most of the NSA stuff's on the high side. And so a lot of us got the blueprints, and we all started sort of building independently a big data solution. But at the same time, we were sort of talking to one another and saying, hey, how are you doing on that solution? How are you doing there? What are you doing to fill these gaps? And eventually we decided it doesn't make sense for us to all work independently from one another. And we all got together and decided, okay, DISA, you're going to handle the baseline for this. You're going to handle configuration management, all the hard stuff. And so they agreed on that, and so now we handle the baseline for the big data solution. And our partners act as the R&D arm for us. And so what they do is they go out and they build solutions, they find new open source technologies or COT solutions, and they figure out how to integrate it, and they hand us that integration package, and then we bring it in through this CAB that we talked about earlier. But think about the cost savings that's going on there now. So now DISA doesn't bear the R&D efforts that have to go on. Everybody kind of shares in it, and so it's a really good news story when it comes to saving funds around the DoD. So some of the examples here is that Army, one of our big partners, has picked this up, and both ARL and some of our cyber areas have picked this up, and they focus on statistical modeling. So I didn't necessarily have statistical modeling in my radar, but they had a group that was really interested in it, so they brought in things like R and Shiny that would help support that. And they're building the analytics, etc. Part of the other thing the nice thing about us having a baseline and all sharing it is that's a common architecture now that we can build analytics for. And so now we can share the analytics. So Army, once again, is focused on the statistical stuff. All we do is we just take it from them if our customers need to use that. And it just works, it works right into the existing environment. They're doing some other stuff with risk modeling. They've got some data scientists on staff, so they're doing a lot of data scientist views, etc. The other partner that we've got is on the Navy side of it. And so the Navy's been working on something called the Navy Tactical Cloud. Now, of course, their mission and their requirements are a bit different because their goal is to get it on ships. We've got it set in the enterprise where we can connect everything. They're trying to get it on ships and have it go out to sea. So they had to think differently about how the requirements were for connectivity back to the mainland. And so they've really been channeling a lot of R&D efforts, looking at different authorization packages, etc., out there that's going to help focus for their mission, but sharing it back once again with the rest of us. We've got Cyber Command that's out there that's using the platform, that's experimenting with the platform, building analytics once again, and sharing those analytics back with the enterprise side of it. And NSA as well is a very tight partner. Once again, they started this blueprint, they started this environment and architecture, and so we're looking that we can share things, analytics at least, from the high side, things that we can downgrade and reuse, and vice versa. Things we come up with, we can share with them. And then there's DISA. And we'll get into more details about some of the stuff that we've been building and the missions that we've been supporting with this.
Before I jump to the next slide, can you touch on our newest stuff coming out, our new release with Elasticsearch?
Sure. So from an end-user requirement perspective, one of the downsides of this big data technology, we're using Ozone Widget Framework currently as building that visualization piece of it. And the only downside to it was that the analysts would come to us and have requirements, and we'd say, okay, we'll build that, but we'll get back to you in about 6 weeks. And they're like, we can't wait 6 weeks. Bad guys out there, I got to get on it right away. So I needed to come up with some kind of a self-serving technology where they could build their own queries into the data, etc. And so what we've done is we've recently brought in a technology called Elasticsearch and Cabana. And what that's doing for us is a couple of things. First off, one of the challenges we have is, remember, I'm bringing in 250, 300 megs, sometimes upwards of 600 meg a second into the system. And it's really busy trying to write this stuff to disk. Along come these obnoxious end users, and they start querying the data and just ruin it for us. So it affects the performance piece of it. And so I've always wanted to split those two things off for a number of reasons, but that's, performance is one of them. And so now what we're able to do is sort of take now specific data sets. So your mission is to look at Switzerland, let's say. And so you go in and you grab all the data about Switzerland and you bring it over here and you provide it to another interface where the analyst can actually go in and manipulate the data and ask 700 questions, and it's not going to affect us performance-wise, but it gives them that flexibility they've been looking for some time now. So we're really hoping, we're going to be releasing this here in the next couple of months, and so we're really hoping that that's going to help the analyst community use this a lot more, and it's going to cut down. The term DevOps is thrown out quite a bit, and it's a really big challenge when you've got a production operational system that you have to support. So hopefully we can sort of offload and give that capability to the end users.
Thanks, Bob. So I want to get into some of the capabilities that we've already started developing. Some of these you guys have heard before, but I want to go over some of them, why we took on the capabilities and how we've evolved since. So when we first started working with the big data platform, we thought, all right, how can we prove out this prototype and take an operation that's pretty complex and make it pretty simple? So our first analytic that we really prototyped with is focused on the variety aspect of big data. So it wasn't lots of data. It wasn't large amounts of data. It really was many different pieces of data from different systems asking different questions. So we had an operator out there that had to come up with answers to questions during the deployment of enterprise email. The system itself, how well it was performing, who was on the system, if the system was down or had to be down, who was it affecting. There were a lot of questions that came in and about around enterprise email. And so what our operations community did is they came to us and said, can you help me answer these questions more quickly? And we said, well, yeah, we can do that, and we can help bring that stuff into one picture. So we were able to mash those different systems together and make a pretty picture that allowed them to answer something that was taking hours or days in a matter of seconds just by looking at the dashboard. So the enterprise email widget and capability is still operational today. It's on the NIPRNet side of our production environment. I think we also have it on the SIPRNet side. And it's used every day. We don't get any phone calls anymore about how enterprise email is performing, at least on the situational awareness side, because this widget's able to help get quick answers about impact at the highest levels. The fight by indicator capability is the next one that we took on, which is a SIPRNet level analytic. And I'm going to lean on Bob and I'm going to lean on Dwayne here in the crowd to help me really get into the particulars of this if you guys are interested. But there's a lot going on with defensive cyber operations, and getting to actionable situational awareness is really the key behind, or the driver behind fight by indicator. So how do we take the analysis that's already been done? How do we take the indicators that are put out there from the intel community or within the department and understand how we're going to stop attacks? How do we take indicators, analyze those indicators, and come up with a countermeasure? So what this system was built around is our ability to bring that in, understand the reports very quickly, and from there we grew a lot of different requirements out of it. How do we make sure that we don't have two analysts working at the same time? How do we make sure that we don't have two agencies working at the same time? How do we make sure that we don't put a countermeasure in place that blocks an offensive operations action that might be occurring? So there's a lot that goes into the fight by indicator when it comes to workflow, interaction, knowledge management, and capabilities to help us understand what all of our operators are doing, and ultimately getting to the point where we can take action on the network and block bad guys from coming in. Touching on a couple of other capabilities that are around this fight by indicator, widgets or analytics we can call them, we have a signature repository that's built in, which allows us to simply catalog and library all the custom signatures that are created around the department. So if you want to understand how to block something, or if someone else has already blocked something, you can go to this library, you can use it, and you can put it into your detection systems. We built a query capability that allows you to go into the data and search the data, simply ask it questions. And then lastly, that I want to touch on is a collaborative environment, which allows really like work planning. It allows operators, allows leaders to come in, assign work to people, to interact with each other, ask questions of each other. It works as an ability to track the work you're doing, where you are with the work, hand work off to others, but really to get at a problem and try to reduce the amount of rework that goes into a lot of the countermeasures that have been done in the past. And we've been able to take what has been hours and days of work and turn it into seconds and minutes of work.
And to build upon it in greater detail, the problem we were having was we get all these PDF reports in from all over the place, and everybody puts them over into their SharePoint, or they go in and they copy and paste certain information out of it, like IP addresses, domain names, etc., put it in a spreadsheet, and then maintain it on the side. And so what we did is we took that, and now the same sort of concept, but we bring these things in and we automatically break them apart, and we look for duplication in existing records. We put it into the database. We allow the analyst to augment that data, add in additional information that they may have from some other report, or they already got knowledge because I've seen that historically. And so they build up this, they take a threat report and build it up with a lot more information. The nice thing about it is that so now we're bringing in sensor data. So we've got the sensor data going in at the same time. And so the analyst can now pivot and start saying, well, where have we seen this across the Doden already? And you can pop in an IP address and do a search, and it'll come back and say, we saw it here on this IDS sensor. We saw it here on this antivirus client. Here's all the different areas, and then map it out across the United States and say this sensor here, this sensor here. So you can sort of see a pattern where this thing is popping up from this malicious actor. And then you want to ask the question, well, maybe somebody else has already seen this. Who else has seen this? And so we have this joint incident management system out there, of which a lot of the folks are inputting the data about the threats and incidents that are occurring within their environment. We bring that data in and make that part of the same search. And so now you can look and say, oh, look, all these other people have seen it. Here's what they've been doing about it. And then the last part of it is what he was talking about is do we have a countermeasure in place already or not? And so we bring that back in, and if we already have a countermeasure, we say no problem. This is, benign sort of threat. Or we don't have a countermeasure. We need to roll this in immediately to some sort of workflow and get the countermeasure out there. And as Dan was stating, the turnaround time frame to get those countermeasures in place is drastically reduced now because of this.
Any questions on fight by indicator?
very good overview you guys did. Also, we deconflict with the intelligence community and law enforcement with those countermeasures using FBI, and it's also our main capability for pushing countermeasures to the security appliances. But thanks.
This is our lead operations guy who really uses the tool day to day. So.
Just a quick question about use and learning. How do you actually work with the tool? Is there a environment that other departments, groups, and organizations can go to actually start messing around with it and not worry about impacting operations?
Dwayne, I don't know. I know we've stood up some instances on Amazon, but we don't. And we've got a pre-production environment that we've established. And so the pre-production environment that we stood up sits physically right beside the production environment. It's a smaller instance of the platform, but what we do is we take the production data and we split it two ways. So we send a copy into production and a copy into pre-production. That gives a couple of different things for us. One of the things is that as new analytics are coming along, a lot of folks will be in a lab or down in a development environment, and the analytic works great down there. But once you turn on the real production data valve, it crashes. And so this gives the opportunity right before we go production, let's get this analytic up there and stress test it. Let's turn on the pull valve of this thing, or maybe the data sets are changing, they're different, etc. Things they didn't expect to see. And so that environment also acts as sort of a user acceptance test area before we go production, but allows folks to come in and once again sort of mess around, not mess up the production data systems.
Bob, I think we glossed over it a little earlier, and since the question came up, can you talk about our cloud-based operational development area?
Absolutely. So back to the concept of I've got this platform now that I'm sharing with everybody, and everybody's building and supporting it. Well, one of the neat things we did is we set up a centralized collaborative environment that all these developers can go to now. And we stood this up on Amazon, and it allows both audiences to come in. So we have one audience that is analytic developers, and they can come in and they can build analytics. And then we've got those that are supporting this big data platform and building new add-ons to it, and it supports them as well. But what's nice is that all the code base is now out there and shared for all the services and all the contributors back into this program. So if I come along and I'm a new analyst or a new analytic builder, all I have to do is I can go and I can reuse any of the code out there. So I'm not starting from scratch. So same concept, sharing the code, sharing the analytics. We've got environments out there where developers can share ideas or ask questions. So they can pose questions out. We've got all of our experts that can answer them back. So it's a really nice environment for this collaboration. And we probably got close to 800 folks, I think. Right, Dwayne? We've got about 800 folks that are now working collaboratively in this environment.
If I may, relating this to an actual system bring up and set up, for example, meeting your risk management framework, security control requirements, what kind of tools do you have or are required, for example, to implement in a system to ensure that you're meeting your CNDSP requirements? Is that part of what you're doing here, or is that another element out there?
Explain a little further. I'm not sure what you mean.
So in order to get your system certified and accredited, especially whether you're in the cloud, on-premise, off-premise, or whatever, you've got to have basically a CNDSP set up, okay? You've got to be connected into the network. And part of the reason for that is incident handling, vulnerability management handling, and such. That would seem to be right in your swim lane here for collecting that type of data. So are you all providing those requirements as far as what types of data we need to feed into these systems or into your CNDSP, or are there tools that you're providing? Does that make sense?
Absolutely.
We have a person ready to answer right behind you there.
All right. So I'm Rob Mooney. I'm the DISA PM for the DISA CNDSP. Yes. So all this information that we're in collaboration with the rest of the incident handlers, or CNDSPs or CDSPs or whatever we want to call them tomorrow. But anyway, so we have all the data that's going in. Our analysts are using that data to perform their CDSP functions. So is there a CDSP? Yes, it's DISA. And yes, we're using this data as a CDSP as well, both at the boundary, because we're in charge of the IAPs, and at the enclaves for our customers. So I hope that answered it.
Sure. So couple more points I can add on to that worth mentioning. So I'm going to have Bob talk about one, but I'll talk about our production environment itself is in an enterprise environment that allows us to actually get the CDSP services from DISA. Where the question was going before, I thought we could talk about a capability we have that I don't have up here is the continuous monitoring and risk scoring system, which is the certification and accreditation data that we actually collect off the network from a continuous monitoring perspective. And we're working right now to take that data and put it into the big data platform to get at those use cases. The pointed answer is, yeah, we can collect any data to get at any problem, but we need that use case. And so if there's a CNA use case or there's a CNA analytic that we want to do, whether it's continuous monitoring or other, yes, we could collect into the system to help visualize it. Bob, before we move off topic, can you talk to how the RDK deploys it as an accredited system?
You have a question?
Sure. Thank you. I'm Hogue Smith. I'm with Nuix. We do cybersecurity solutions for the government and businesses. And I really like this use case. Thank you guys for bringing some clarity into what I know is a really complex topic. I was just curious if there are additional data sources for this particular use case, either on the unstructured side, like the intelligence reporting side, or on the structured side from sensors that you guys think would be helpful in advancing this and making this better at detecting cyber events.
It really depends on the use case. Kind of back to, we would turn to our analysts and say, hey, what additional data feeds would support you better? What additional threat feeds, et cetera, without duplicating and getting too much from a threat information perspective. But that's kind of how we flow with it, adding in the new data sets and threat feeds, et cetera, to it. One point that I wanted to bring up was when we first started this system, one of our goals was to bring together not just the C&D, DCO kind of data, but that operational data as well. So if you think through a couple of use cases that we've got out there, DDoS detection. So if I'm on the network side, I'm in a NOC, and I'm watching my routers, and all of a sudden the processor gets pegged, I may be like, what the heck is going on here? But now I'm going to couple up either the DDoS system or the antivirus systems and say, look, we've got a virus outbreak going over here in this area. And so bringing those two data sets together, I think is really going to expand this out beyond what just typical C&D is considered today.
Dwayne, I don't know if you can talk about it in an unclassified situation, but can you talk to some of the data sets that we've brought in since starting with indicators?
Sure. On the SIPR side, we've basically automated the ingest of multiple in the 20, 30 kind of range intel reports, cyber threat reports. We also have within SIPR the GIMS data as well as the NIST vulnerability data, so you can look at vulnerabilities associated with threats, active threats. On the NIPR side, we're able to access all the WCF web traffic log data, search through it to see if those threats also are active on the network. We have EMSG, email gateway data. We have a whole host of JRSS-based data sets all within the same cloud. So when you start talking about looking at threats from a Tier 1, Tier 2 level, we can now run active analytics to say how many times has this port been seen both at the JRSS level and also at the Tier 1. And if the block is being done at the Tier 1 but not the Tier 2, why is that, or vice versa? So all that stuff is now within the scope and realm of what's active in CSAC today, but we've got a long way to go to get more data, more analytics on, to meet all these other use cases.
And correct me if I'm wrong, that was an evolution of the analytic that helped us to, the question that came back to us was, how effective is the countermeasure we're putting in place? And that's what this data helps us to figure out.
Correct. So Fight by Indicator allowed us to automate the countermeasure deployment. So we were able to understand threats, produce the countermeasure, and deploy those countermeasures more effectively. But what still wasn't answered was, is it an effective countermeasure? So now we're able to run an analytic that says, based upon all the blocks you said we're blocking, are we actively blocking all those today in the last 24 hours? And if not, it alerts. When I say alert, it brings it back into a result set that allows the analyst to say, why is this thing not being blocked? And we saw a whole bunch of results when we first did this because of blue code redirects, and we were taking that as a positive hit, but we realized it's false positive. So we refined that, and we still find some interesting things as we start looking at this. What we thought was supposed to be blocked because of Fight by Indicator is allowed because somebody else put it in a global allow list. So you start asking those questions of why those things are happening now. We can at least ask those questions because we can see it.
And that's an example as we employ an analytic where we can actually see from our data scientists more data we need, more things we need to understand to really get at the use case of understanding. So this next capability, the secret sauce, is probably something that I can't talk to, but the capability started off as an insider threat use case. It came to us as, how do we detect data exfiltration? How do we detect behavior from users that really shouldn't be occurring? It could be off-hours things. It could just be weird behavior. And when we started looking at the use case, we started realizing that this doesn't have to just be an insider threat. We realized it could be any anomalous behavior. So it could be an insider threat, it could be a nation state, it could be any enemy trying to do behavior on our network that is otherwise looks normal. So this capability allows us to dig into that data using data sets from the host all the way up to the perimeter and correlating those. And this is probably our most complex analytics when it comes to understanding behavior and heuristic behaviors that we see coming off the network. The analytic itself is hosted, Bob talked about it earlier, in our private secret network, and that's where we're allowed to bring unclassified and classified data into one environment and interrogate it.
One of the interesting components of this that helped support it was one of our original requirements was to do attribute-based access control. And so for years now, we've been building in all the plumbing, everything we need to do attribute-based access control, or ABAC. This is the first solution or capability that's taking advantage of that plumbing, all that infrastructure now. As you know, there's concerns around each of those folks that are responsible for looking at insider threats and making sure that we're not leaking information we shouldn't, as soon as we get down to the individual cases. So ABAC is a good spin-off and a good use within this.
So this is my last slide. I don't know how we're doing on time, but I might have to talk really slow. What we're trying to illustrate with this side is not knowing everyone who's going to be in the audience, but we figure we were going to have partners and people from government and with us in this audience, and as well as industry partners. And so we wanted to talk about where we see opportunity for assists, where we see opportunity for evolution of the big data platform, and things that I guess we would ask for or we could use input into, because we don't necessarily have all the answers. So looking at the top one, commitment to open architecture and standards. So there are a lot of capabilities out there commercially that come to us and say, hey, we can provide you situational awareness, we can provide you analytics, but they often require it to come with the back end or an infrastructure that goes along with that. And that's proprietary and doesn't necessarily interact with another infrastructure from another company. So I might have two great ideas that have two completely different back ends, and that's how I get a system set up like I've had for the last 15 years, which is stovepipe systems. And so what we're looking for is a way to be able to bring open standards and open ideas in that don't require me to rip out my infrastructure. Augmenting my infrastructure, changing my infrastructure, that's one thing. And working with our partners and with our board and our stakeholders, we can do that. We can interact with other capabilities. So what we're trying to do is find a way to build on, provide a visualization, but not necessarily always rip out the plumbing. From an enterprise architecture standpoint, and we run into this problem now with a couple of programs, we haven't hit it yet with Big Data Platform, but I will talk about a challenge in that area, is we support the Department of Defense at the enterprise. We support millions of users, and oftentimes capabilities don't necessarily scale to support them from a sensors perspective and aggregating all that data. So we have roll-ups and tiers and understanding how that works. But what we need help with is systems that scale or can build on a scale in the DoD environment. So bring us capabilities or help us understand capabilities that you have that can scale to millions of users, because we're not one operation, we're many operations, and we're not one command and control, we're many commands and control. So how do we bring these capabilities together to provide the right visualization at the right layers, but not overwhelm the system in a way that it can't perform? We talked earlier about data standards and tagging and how we understand data, the legal about data, and understanding standards and making data across different products, whether it's different companies or different products along the way. How do we understand that data in a way that we don't have to constantly keep re-architecting the analytics in the back end to understand that data.
So let me build on that just a little bit more. As part of the solution, one of the things, remember the goal is to share analytics. So whatever analytic you build, whatever analytic I build, we all swap back and forth. One of the key components is I got to have an architecture that matches, but I got to have a data schema that matches. And so that's definitely been one of our biggest challenges. And so we've employed solutions to date that normalize that data going in there. What we normalize it to is nothing official. There's no data standard we're necessarily normalizing to on the input. It's more of a community effort right now across DoD. So each of the services is stepping in and saying, I've got my sensor that's coming in, and I call source IP this, and I call source port this. Do we already have a field out there that matches that? And so we've developed a solution that allows folks to sift through and determine what's already been normalized and how can I reuse that same normalized information. But that's key for us going forward. And of course, even once we get together and we all agree on something, it falls apart pretty fast. And so we're really focused on how do we keep that energy alive and how do we keep that normalization together. And what we talked about earlier on the governance team, we've stood up this governance board across the DoD so we can help get everybody to agree on what this field name should be, what we all know. But if you think about it from an analytic perspective, it benefits us analysts. As I talked about a business intelligence kind of interface, if they've got to run queries on one particular field and they don't know what it is, or I got 5 fields that I got to run my query against, it's just too confusing. So I just want to reiterate that's a key aspect for us, is keeping this data normalized as we bring in more and more data sets.
The challenge we talked on earlier was understanding the data and looking at the data. And we see a huge drought in data scientists. And we look out to our mission partners and we look out to our industry partners to encourage this field, to encourage more data scientists, bring data scientists into your team, bring data scientists into your operation, because the more we can understand the data, the more we can understand what we can do with the data. Again, I talked about rolling the ball when it comes to understanding a use case, and sometimes understanding the data is the core of doing that. You can think of it as the chicken and egg scenario.
Test 1, 2, 3.
Choke on this thing. So collaboration environment and leveraging our governance portal to understand how we facilitate information and sharing to reduce redundant efforts is huge what we're pushing for. This is less of an industry side of things and more on the mission partner side of things. How do we make sure we're not all working on the same thing? And how can we come together to work as partners? And being part of our governance board, being part of our CAB and our summit helps us to reduce that redundancy. Part of data scientists and part of the DevOps environments that we build is understanding how we can automate getting capabilities to the users and operators more quickly. So Bob talked about what we're trying to do here with Elasticsearch and Cabana to be able to bring that DevOps environment to the user so they can develop their own situational awareness. We encourage mission partners to take advantage of something like that, but we also encourage our industry to build environments that we can do more of that with. And lastly, we look at leveraging data repositories. And so how do we find the sources of data? How do we not store data 88 times and cost the government tons and tons of money to store the same data over and over and over again? How can we leverage the big data platform? How can we leverage other storage solutions out there that aren't necessarily processing data but just storing it as sources that we can tap, as opposed to everybody tapping one single source 100 times? We can tap one source, move it to a place, and then that's where we can interrogate that data. Anything after that? So that concludes our presentation. I want to open it up to really any questions you guys have.
Can't hear you. Can you step to the mic, please, ma'am?
You briefly mentioned scalabilities as an issue. Could you expand on that?
Sure. So when we look at data as a driving factor in how we scale, we go back to that volume, variety, and velocity pieces. And so we actually have this challenge with one of our programs now. We're looking to get a negative correlation between those aspects. And so the more that you want to interrogate that data or query it, You cause a performance hit when you have too much data to sift through, when you have too many pieces of data, or you have too much data coming in too quickly. So we look at a system like the big data platform that can scale horizontally, can ingest data with many processors, as opposed to one system that acts as a funnel.
And to add on to that, there's always the concept of real time that everybody likes to throw around. And the reality behind real time and manipulating it and working with it, processing it, adding policy to it, is a really astronomical thought. And so, I always say that Dwayne will argue on this, but this is not a real-time system. This is Hadoop-based. This is batch-based. So you're going to be getting the data. You're going to be able to run the analytics, but it might take 15 minutes from the time the data leaves the sensor to the time you can see it visually. So we've got alternate solutions that we've got in place. We utilize SIMs, etc., that really focus on let's get the data into memory, and we've got the correlation rules in memory, and get that done fast. And so the two work together to provide that analytic situational awareness. But the big data platform doesn't necessarily do it alone, especially when it comes to the concept of real time. And scaling real time is just a really intense thought to think about when it comes to the amount of memory and the amount of processing and servers that you need to put in place to do that.
I was wondering if you could go all the way back to the beginning and talk again about the use cases. The thing that I'm trying to get my arms around is how the data gets put into the big data platform. Mm-hmm. So I think that you said you just don't collect all the sensor data, or do you? Okay, so whoever the community is that does this, comes in with a use case and says, I need this data.
Right.
And then some way you guys vet that and decide to begin collecting that data. If I'm saying things that aren't accurate, let me know. I'm trying to put this all together.
Right. So in theory, you're going to come to us and say, I need the capability to do X, Y, and Z. And back to that data scientist concept. So let's say I've got a data scientist on staff, and the data scientist can go out and I can say, what that person needs to see is going to come from this data set and this data set. And within that data set, it's going to be this field and this field and this field. And really identify it down to that very specific information. And so then we work with that source, sensor, whatever it is, to really understand that data set. And then we got to figure out how to funnel it in. So whether they're going to push it to us, we're going to pull it from their database, all that stuff needs to be figured out. And then we're going to bring it in, and we're going to figure out back to the normalizing of the data. So now I'm going to write it into the system. And I got to figure out how I'm going to normalize it. So your new sensor, maybe it looks like a blue code, it looks like a source fire, it looks like something, but I got to marry up those fields. Does that make sense? From the normalizing, and then build that visualization front end on it that's going to call all the right data for you. So there's a lot of steps to bringing that data from the first time you show up and say, I wish I could see X, Y, and Z, analyzing the data, and then bringing it in and showing it to you visually.
Okay, then I have a question about the analytics. So at the beginning you said, I believe that you have 40 products, analytic products.
No, it's 40 open source capabilities that support this big data platform. We've got about 180 widgets or analytics that are riding on top of it through the CSAC interface.
Okay, so then later on you talked about other analytics. So I sort of got the impression that that your set of widgets and perhaps analytics, I'm not sure, because I understand analytics is 40.
No.
And the widgets is 180 on top of that.
No, the supporting software is 40 different pieces of open source software.
Okay.
That's everything I need to run the infrastructure. Everything I need to do the ingest, write it to a database or several databases, and then provide a front end for you.
Okay, now I understand. But you can expand. If I have a great capability not capability, I'm not sure what terms you guys use. Tool, I guess.
Yep.
If I have an analytic tool, I can bring that forward to perhaps be put in if it meets all those criteria that you briefed.
Absolutely.
Okay, I got it. Thank you very much.
Yep. So we do that all the time, right? The open source community is constantly coming up with new stuff. And so we're constantly interjecting new things that'll do things better, faster for those folks. Any other questions? Thoughts?
All right, thank you, everybody.
Thank you, everyone.
Thank you, Mr. Barr. Hart and Ms. Galandrith, for your perspective on everything. We will reconvene at this session at 11:50.